Hello and welcome to the second lesson, which is on representing vectors on a graph. Remember, during our last lesson, we spoke about vectors in the column form and vectors in the magnitude-bearing form. So we have questions here, 3 questions in the column form and 2 questions in the magnitude-bearing form. So it says, express the following vectors graphically. So we have vector AB equal to 3 and 4. So let's see how do we represent this particular vector on a graph. So first of all, I'm going to draw my Cartesian plane. Right? And then right. So here I know this is my y-axis. And this is my x-axis, right? So it says vector AB. And remember, during our last lesson, we said the first letter tells you where you're starting from. So it tells me that I'm starting from A, the origin. I'm starting from A. And the 3 is my x. It moves on the x-axis, and it's positive, right? It's positive. So I'm looking for 3 on the x-axis. So it's just 3. You're moving 3 units on the x-axis. Right, so I'm saying 1, 2, 3. We are just estimating. So I move 3. I'm going to write 3 here. And I know this is my y. So I'm moving on the y-axis. But is it positive or negative? It's positive. So I'm looking for positive 4. So I'm moving 4 units on the y-axis. So I come here and I write my 4 here. You're estimating. Right, 4. So our question is, if 3 is moving up, four coming this way, their point of intersection is going to be our B. Right? So basically the question is, if someone is at point A and want to travel to point B, what will you say? You say, okay, you're going to move 3 units to the east and move 4 units north. So basically, you're just giving a direction. So if we want to represent it as a vector, we now draw our line straight. And remember, we say vectors, you must use the arrow to show where it's moving from. Right? You're moving from A to B, and that's it, you are done. Right, so let's look at the next one. We have vector OA, right? I have vector OA. It means I'm moving from O to A. So let me draw my Cartesian plane. Right? I know my y is here, my x is here, right? I'm moving from O, so my my starting point is O, right? But this is my x and y. I'm looking for negative. This is positive. I'm moving to the right-hand side of x if you're positive, but to the left, I want negative 4. So I'm moving 4 units on the negative part. So I'm representing my negative 4 here, but I'm looking for positive 5 on the y. So I just got to make sure that the 5 is a bit higher because I'm looking for 4 and 5. So let me represent 5 here. I know it's positive 5, so I write it here. Right? So if I'm moving from negative 4, so the question you just got to ask yourself is, if someone is at O and want to get to the point A, how are you going to give the person direction? I'm going to say, okay, move 4 units on the left. So I've moved 4 units on the left, and I'll say, okay, move 5 units to your far north. So I'm moving from here. And 5 is here. So the point of intersection is going to be my A. Right? And I know I'm moving from O all the way to A. So I use my arrow. Right? To show where I'm moving from. That's just basically how you represent on the graph. Let's look at the next one. This one we have two negatives, right? So I draw my Cartesian plane. I know this is gonna be my y, this is my x, right? And I'm looking for both negatives. Remember, the negative part of x is here and negative part of y. So I'm looking for -3. Remember, this 3 units on the negative part. So I have my -3 here. And I'm looking for -4 on the y-axis. The top part is positive. I know the whole of this is positive, but I'm looking for negative. So I come down here, I'm looking for -4. So I write my -4 here, right? But remember, we were supposed to start from where? PQ is moving from PQ. So I'm starting from P, and I'm moving to Q. So let's see where is going to be the point of intersection. And 4 is also moving towards. Then I know the point of intersection is here, right? And this is Q, right? So it tells me I'm moving all the way here. Remember, you are moving from P to Q, so you use the arrow. Don't forget, you gotta always show where it's moving towards. Remember, the first one was found in the first quadrant. The second one, we found it in the fourth quadrant, but this one is in what? The third quadrant. So, depending on how it is shown, either it's positive, positive, negative, negative, then you should be able to know where to draw it, right? Let's move on. For this one, it's not in the column form, right? It's in the what? Magnitude bearing form. Still, I just have to draw my Cartesian plane. Remember, if I have a Cartesian plane like this, remember we're looking at bearing. So this is going to be 0 degrees, 90 degrees, 180 degrees. This is 270. And when I move around, I'm going to get 360 degrees here, right? And always remember, we say graph or bearings or vectors are measured from the geographical node. And the same way, we know this is, let me use a different color here. I know this is my north, this is south, this is east, and this is west. And we say bearings are measured clockwise. Clockwise from what? The geographical node. So let me write my Cartesian plane. So we now want to find vector xy, but it's in the magnitude bearing form. So I'll draw my Cartesian plane here. I know this is my north and it starts from 0, right? And you say we're starting from x. So my point of starting is x. But we say it's 5 centimeters. So it tells you the magnitude. But we say 50 degrees. So if this is 90 degrees, I want 50 degrees. It tells me that it's going to be found in this origin. Because if I move to the second origin, this is 90, and then this is 180 degrees. This is 270 degrees. And I want 50 degrees, right? So I know when I divide it exactly into 2, it's going to be 45. So I have to make sure that, oh, it's a bit, I open it a bit because I'm looking for 50 degrees. So let me, from here, right? And I'm going to say this is going to be the point Y. And I know I'm moving because remember we say 50 degrees. So I'm going to say between this angle and this particular angle is going to be my 50 degrees. Right? And we know that it's moving. We say it's moving from X to Y, from the point X to Y. So I bring my arrow. And we say what is the length? 5 centimeters. So I write my 5 centimeters on it. Right? This is much easier. Since you know the angle, just you measure the angle. You know, draw your Cartesian plane. Depending on the angle they give you, then you know where the quadrant it is going to fall in. Let's move on. Here we have PQ. Right? So I have my PQ. Let me draw my line. And always measure from your geographical note, right? I know I'm starting from 0. This is my 90. This is going to be my 180. And I have 270 here, right? And I'm measuring from the geographical note. It says PQ. It means I'm starting from P and moving all the way to Q, 13 kilometers, right? But it says 157. So from 0 here, from 90, meaning I'm not going to fall between here because it says 157. But from 90 to 180, meaning it's going to fall within this quadrant, right? It's going to fall within this quadrant. If I divide this into 2 equal parts, it's going to be 45. If I add 45 to 90, it's going to be 135, meaning I have to enlarging it a bit, getting a bit closer to the 180. So I just have to move all the way here. Remember, all easily, if you want it an easy way, if I just have to ask myself, what do I have to add to 90 to be able to get 157? Right? So it tells you that if I add 67 to this, I'm going to get what? 157. So I just have to go all the way down here. Right? And I say, I'm adding this angle. I'm adding this angle to be what? 67. Because when I add this to that, then from all the way here, then I can see all the way this part, the whole of this, is now going to be the 157 that I'm looking for. And it's from P to Q. So this is going to be my Q. And I know I'm moving from P to Q, so I use this to show. But then how many kilometers? I write it on top, 13 kilometers. All right, guys, thank you so much. So let's move on and see what we have here. So here we say we're having magnitude of a column vector. What do we mean by the magnitude of a column vector? The magnitude of a vector, say AB, is the length of the line segment. That's what we've been talking about. Magnitude just basically talk about the length. So the magnitude of a vector AB is denoted by the absolute. Normally we call this absolute value. But this, if I say magnitude of, say, if I have vector XY, and I say solve or work out for the magnitude of vector XY, it's just going to be like this. You write XY, and then you ring these symbols, which is also called what? The absolute values, right? Okay, so let's look. It says if vector AB is equal to X and Y in column form, then the magnitude, anytime you see this, anytime I see this, I know I'm going to read it as the magnitude. Anytime you see this, you read it as the magnitude of AB. So the magnitude of AB is going to be equal to the square root of X squared plus Y squared. Easily. So, all right, so let's look at examples we have. It says, find the magnitude of the following vectors. We have vector AB equal to 3, 4. So the 3 is going to be your X, and the 4 is your Y. So if I want to solve for the magnitude of AB, I know magnitude AB, I'm going to write AB and bring the symbol. It's going to be equal to the X squared, the square root of the X squared. Now my X is 3, so I'm going to write 3 squared plus the square root of the Y squared, which is 4 squared, right? So I have my AB, the magnitude AB, to be equal to the square root of 3, that is, sorry, 3 squared is going to give me 9, plus 4 squared, that's 16, right? So I know the magnitude of AB is now going to be equal to 9 plus 16, which is going to give me 25. which is equal to 5. So it tells me that the magnitude or the length of the vector AB is going to be equal to 5. Sometimes, depending on the question, it could maybe 5 centimeters, 5 kilometers, and whatever. Pause the video and work on it. All right, so when we look at the PQ, we say the magnitude of PQ. So I write my PQ is going to be equal to the x square root of the x squared. Remember, our x now is negative. So just don't write negative 15 squared. If you write just negative 15 squared and put into a calculator, it's going to give you a negative answer. Always put it in parentheses and put the square plus 8 squared, right? So I know my PQ, the magnitude of the PQ, is going to be equal to what? When I punch in negative 15 squared, right, I'm going to have 225. So I have my 225 plus 8 squared, which is going to give me 64. Right? Then after that, I just have to put those two together. I have 225 plus this is going to give me 289. Then I take the square root of that, right? So my PQ. So the magnitude of PQ is going to be what? 17. Thank you so much for taking your time to watch this lesson. See you in the next lesson.